Q8839. 1. There are three basic types of DC motors: series, shunt, and compound. 2. In the series motor, the field windings, consisting of relatively few turns of heavy wire, are connected in series with the armature winding. Regarding the above statements: A. Only one is true. B. Only two is true. C. Both 1 and 2 are true. The correct answer is C. Statement 1. There are three basic types of DC motors: series, shunt, and compound. This statement is true. DC motors can be categorized into three main types: series, shunt, and compound. These types differ in how the field windings and armature windings are connected. Statement 2. In the series motor, the field windings, consisting of relatively few turns of heavy wire, are connected in series with the armature winding. This statement is also true. In a series DC motor, the field windings and armature windings are connected in series, which means the same current flows through both windings. The field windings typically consist of relatively few turns of heavy wire to handle the high current. 8840. What is the appropriate method for installing pre-insulated terminal lugs and splices to electric wires? A. Using a crimping tool to secure the terminal lug. B. Soldering the terminal lug to the end of the wire. C. Soldering the exposed wire prior to crimping on the terminal lug. The correct answer is A. The appropriate method for installing pre-insulated terminal lugs and splices to electric wires is to use a crimping tool. Crimping involves mechanically compressing the terminal lug or splice onto the wire using a specialized tool designed for this purpose. Crimping provides a secure and reliable electrical connection. Using a crimping tool to secure the terminal lug is the correct choice because it ensures proper connection and avoids the potential issues associated with soldering, such as overheating the wire, introducing excess resistance, or weakening the joint. 8841. Which of the following factors must be taken into consideration when determining the wire size to use for an aircraft installation? A. Allowable power loss, permissible voltage drop, current carrying capability of the conductor, type of load. B. Mechanical strength, allowable power loss, resistance of current return path through the aircraft structure, type of load. C. Allowable power loss, resistance of current path through the aircraft structure, type of load. The correct answer is A. When determining the wire size to use for an aircraft installation, several factors need to be taken into consideration. Allowable power loss. This factor relates to the amount of power that can be lost in the wire due to resistance. Different systems may have specific requirements for allowable power loss, and the wire size should be selected to minimize power loss within the acceptable limits. Permissible voltage drop. Voltage drop refers to the reduction in voltage that occurs as current flows through the wire. Depending on the application, there may be limits on the acceptable voltage drop, especially in sensitive electrical systems. Wire size should be chosen to keep the voltage drop within the permissible range. Current carrying capability of the conductor. The wire size must be able to handle the maximum current that will flow through it without exceeding its current carrying capacity. Choosing a wire size that can adequately handle the expected current ensures safe and efficient operation. Type of load. Different loads, such as resistive, inductive, or capacitive, can have varying effects on the wire. The type of load influences factors such as power factor, voltage regulation, and reactive power. These considerations may impact the choice of wire size. 8842. When selecting hardware for attaching bonding to an aircraft structure, which of the following should be considered? A. Mechanical strength, ease of installation, amount of current to be carried. B. Permissible voltage drop, amount of current to be carried, type of load. C. Mechanical strength, allowable power loss, ease of installation. The correct answer is A. When selecting hardware for attaching bonding to an aircraft structure, several factors should be considered. Mechanical strength. The hardware used for bonding should have sufficient strength to withstand the forces and stresses that may be encountered during aircraft operation, including vibrations, temperature changes, and mechanical loads. Ease of installation. The hardware should be designed for easy installation to ensure efficient and reliable bonding. This includes considerations such as accessibility, compatibility with the aircraft structure, and simplicity of the installation process. Amount of current to be carried. The hardware must be capable of carrying the required amount of electrical current for bonding purposes. This is important to maintain effective electrical continuity throughout the aircraft structure. Option A includes all the relevant factors for selecting hardware for attaching bonding to an aircraft structure. It takes into account mechanical strength, ease of installation, and the amount of current to be carried. Therefore, option A is the correct choice. 8843. How should the splices be arranged if several are located in an electrical wire bundle? A. Staggered along the length of the bundle. B. Grouped together to facilitate inspection. C. Splicing within wire bundles is not permitted. The correct answer is A. Then multiple splices are located in an electrical wire bundle. It is recommended to arrange them in a staggered manner along the length of the bundle. This arrangement helps to prevent a thick cluster of splices in one area, which can lead to increased bulk and potential interference with other wires or components. By staggering the splices, the overall diameter of the bundle can be kept relatively consistent, allowing for easier routing and installation. It also helps to distribute any potential stress or strain more evenly along the length of the bundle. Therefore, option A, staggering the splices along the length of the bundle, is the appropriate method for arranging splices in an electrical wire bundle.